I need you to be this part of your notes. We're talking about displacement of a moving object. Or given an equation for the displacement of a moving object, find an equation for its velocity and an equation for its acceleration. This is mostly over standard D6, although there's other standards kind of thrown in there as working. Alright, so several times in this course so far we've dealt with finding the velocity or acceleration of a moving object at a particular x value. We're now going to be able to find an equation to represent velocity and acceleration at any point if we know the position equation of the object. So here's the long explanation of the overarching idea that connects displacement, velocity, and acceleration. Let me make sure I have the right. Oh boy. There we go. Alright, so suppose we have a situation of a football punted in the air. As it rises and falls, its displacement in relationship to the ground is a function of time, but specifically we're going to say number of seconds since it was punted. Suppose that by experiment it is found that the position function of the football at any time is given by this equation. Y equals negative 16 t squared plus 37t plus 3, where y is the football's displacement in feet and t is the number of seconds since it was punted. The velocity of the ball gives it speed and direction in which it's going. Because velocity is an instantaneous rate of change, which is change at any instant, it is a derivative. For the above equation, the derivative, so y prime, we can actually label that velocity, because velocity is a rate of change. And we can use the power rule here because it's a polynomial. So we'd have negative 32t plus 37 if you use the power rule. Another way to write this, that I'm just going to throw in there because we're going to probably use it at times, dy over dt. It's another way to write y prime or f prime of x. What that means, though, specifically, is it's the derivative of y with respect to time. So how fast y is changing in terms of time. The reason we use this is called Leibniz notation. It's a different way to write derivatives, but it tends to be a little bit better and more clear later on when we have to do specific problems where we might have more than just two variables going on. So I'm going to throw it in once in a while now just so that we get used to it by the time we get there. Okay, to find the velocity at any particular time, we're going to simply substitute for t. So here's some examples. If I want to find the velocity at time equals 1, well, your velocity or derivative of y with respect to time is that function. So this is the function that gives me the velocity at any time of this football whose movement is actually described by that quadratic. So if we plug that at 1 in for t, negative 32 plus 37 gives me 5. And my units here are going to be feet per second. That's the other way, or the other reason I like Leibniz notation is because it reminds us that our units should be a fraction of some sort, so feet per second. What this is telling me about the football is that the position of the football is increasing at t equals 1 because the velocity is positive. Okay? Which hopefully 1 second after someone kicks the football, it's still going to be going up in an upward motion. Hopefully it hasn't already started falling. So that would make sense for this case. Now 5 feet per second isn't moving very fast, so it might be really close to the top before it actually starts coming back down. So let's try t equals 2. Okay, again, using your velocity function, we're going to plug in 2 now for t. When you do that, you end up getting negative 27 feet per second. So what this is telling you about, your football is at the position of the football is decreasing, or that the football is on its way down. Okay, so we've kind of touched on aspects of this concept already, but this is going to be focusing a little bit more specifically on velocity and acceleration and how they work together. All right, so go ahead and flip. I'm not sure how much we're going to get through here, but at least if we have a good introduction to go off of, we'll be set for tomorrow. Let me find the right thing. Okay. So the other part of this is that speed is the absolute value velocity. When you're talking about how fast someone's going, usually you don't say they're going negative feet per second. You're going to say they're going 40 miles per hour. Because specifically there, you're not worried about what direction they're going. You're just worried about how fast they're going. So speed. Speed tells how fast an object is going without regard to its direction. So when t equals 1, the speed of the football is 5 feet per second. When t equals 2, the speed of the football is 27 feet per second. So the football is traveling faster, which makes sense because, like I said before, 5 feet per second isn't very fast, but it's probably like somewhere on the upward stroke. Hey. I'm videotaping my lessons for calculus.
What time are you going to be leaving here today?
Okay, so sorry about that. Mr. Price interrupted. You can yell at him tomorrow. All right. I forget what I was talking about. So we'll pick up where we left off. All right. The negative velocity when t equals 2 indicates that the displacement is decreasing or the ball is falling toward the ground. Although the ball is traveling faster at t equals 2, its velocity is less because negative 27 is less than 5. So note that the velocity changes from t1 to t2. The instantaneous rate of change in velocity is called acceleration. So acceleration is how quickly velocity changes. It's the derivative of velocity. Therefore, the equation that represents acceleration is going to be dv over dt in Leibniz notation because you're taking the derivative of velocity with respect to time. And if you go back to your original function here of what velocity was, the derivative of that is just going to be negative 32. And the units on that will be feet per second squared. Because if you take the double derivative here, you have feet per second divided by seconds for 1. So if you flip and multiply your units, that's where you get the second squares from. Negative acceleration means that the velocity is decreasing. In this instance, velocity decreases from 1 to 2 because the values of velocity decrease from 5 to negative 27. Also, at t equals 2, the speed is increasing even though velocity is decreasing. Speed went to from 5 to 27. The ball is going faster in the negative direction. To tell quickly whether an object is speeding up or slowing down, compare the signs of the velocity and acceleration as shown below. Now, I will tell you that very often in a free response problem, you have to do this, and this is super easy if you remember what we're going to write down here. So, if you want to see if it's speeding up or slowing down, if velocity and acceleration have the same sign, the object is speeding up. If velocity and acceleration have the opposite sign, the object is slowing down. So same signs, speeding up. So the other way to remember it, velocity and acceleration, if they're both going in the positive direction, or both going in the negative direction, speeding up. Okay? If you have opposites, or the other way, this means they're slowing down. Okay? So to determine quickly, usually if they ask you, are they speeding up or slowing down at a particular time, they've already made you do the work of finding the velocity function and the acceleration function, and then they're focusing in, on maybe one point, and you have to use that data, whether both signs are positive or both signs are negative, to tell me if it's speeding up or slowing down. In this case, because the acceleration is negative and our velocity for our t equals 2 is negative, that means you're speeding up in the negative direction because both of them have the same sign. Okay, we'll touch on this, again. Go ahead and flip. All right, I think the thing that I want to end with today, before maybe we do some of these examples together, or I might just have another homework video tomorrow. This one will be a short one. Is to write down your position function, your acceleration function, so forth and so on. Okay, your position function in feet from algebra 2 is s of t equals negative 16t squared plus b sub o t plus s sub o. Remember, s sub o is your initial height, b sub o is your initial velocity, s of t is your desired height. In meters, same thing, except you have negative 4.9t squared plus b sub ot plus s sub o. Okay, your velocity function will be s prime of t, which will always be negative 32t plus v sub o. Acceleration function is the double derivative, or the second derivative. Oh, I should have labeled this as velocity too. Okay, so you can label it as s prime, or you can label it as velocity. This one you can label it as a of t for acceleration, or s double prime. But that will be negative 32. Over here, s prime of t will be negative 9.8 t plus v sub o. Double prime, negative 9.8. If they don't give you a position function, this is where you have to come to make your position function. Position function is just that. It is a function setup that gives you the position of anything in motion in terms of being thrown or dropped. Okay, so we're going to either in the homework video tomorrow, or actually in class tomorrow, start with example 1 on this page, but that will give us a good intro to that section, then we can just deal with actual